anytime you want to have one value and figure out how far it is between two other values, that's called mapping. Sometimes that's called remapping, or again, normalization, because it returns a value between 0 and 1. So let's say you have a value, and let's say my value is 5, and I want to return how far it is between two other values, like an input value. Let's say the input value is 0. Let's just do easy math. Output value is 10. And of course, you don't need a function to tell you that halfway between 0 and 10 is 0.5, and 2, 0.2, etc. But of course, then if I just make it up some numbers here, like 76 and 258, 225,000, probably then that then becomes like, hey, 543. How far is that between that number and that number? Well, now the math is really hard. But as it turns out, we can build a function that'll just go ahead and return that for us. And I'm just going to go ahead and call my map. And what we're going to do is we're going to call my map. Map will return the difference between 0 to 1 between two numbers. And it's a utility. So I'm going to say map. Remember, I'm trying to get numbers between 0 and 1 for my index value. I want to feed it the index value. And then if the index is between 0 and 3, I want to return 0 to 1. And then if it's between 3 and 6, then it will return 0 to 1. If it's 6 and 1, 0 to 1. And that's if I was dividing this into, like 3 bits. 0, 0.333, 0.333, 0.666 would be, even distribution between these guys. So that's what I'm trying to do. I want to get it to repeat 0 to 1, 0 to 1, 0 to 1. And so my map function, let's see, I'm going to need a number. And then I'm going to need two other numbers. And I'm just going to do, this is just, you could get more complicated with this, but I think this will be fairly instructive. Float, let's say the input minimum and the input maximum. And then we want to return some number. And the number is going to be basically this number, but in relation, the relationship between these two numbers. So let's take our example, our simple math example again of 0 and 10. And the number that we're going to feed it is 5 as our input. So that would go in there, and that would go in there, and that would go in there. And our expectation is that it would return 0.5. And if this number that we fed would be 10, it would return a 1. And if this number we fed would be a 0, it would return a 0. So it's always going to return a value between 0 and 1. So how can we do that? Well, first we need the relationship between these two numbers. And to do that, all we really have to do is get the difference between the two of them. So in this case, actually, once again, the math is incredibly easy. 10 minus 0, the difference between 10 and 0 is 10. So let's go ahead and let's get that. The difference between the inputs is equal to the max minus the min. So the difference between 10 and 0 is 10. It's got to, but if you could think about this, then if let's say this bottom number was 5, the difference between 10 and 5 is a value of 5. And if this, let's say this was -7 and this was -1, actually, because these are both negatives, when you subtract, you're going to get a positive, and and you can return the value of 6. That there's a total difference of 6 between these things. Let me make sure I spell difference between the inputs. Okay, so now you have the difference between the inputs. You need to get the difference between your target number and the input of the minimum. So basically, you want to get the difference between the numbers. So we're going to actually just kind of do this twice, right? Like the difference between the inputs, and then we'll get the difference between the number, the target number that we pass in, and the minimum. So we've got the difference in value between these two, and we've got the difference in value between these two. And then we can return this just divided by that. So once again, let's do this with really easy math, and let's run through our function. So let's say our input minimum is 0 and our input maximum is 10, and we're going to float in a number of 5. We're going to pass in a value of 5. So the difference between 10 and 0 is 10, so the result of that would be 10. The result of 5 and 0 would be 5. And then the difference between 5 divided by 10 is, of course, we get half, 0.5. And believe it or not, this little formula will work for any numbers. We can pass any two numbers here, and we can figure out from a percentage how much was between the two of them based on this number. So that's actually what we're looking for here. We want to pass this number in, and then we always want to return 0 and 1 for our index. So that's called mapping. And actually, you're going to find this all over computer graphics when you start looking. This remap function, this is going to be your best friend. All the time you want to take a value and map it between two target values. In fact, so much that, I mean, yeah, what the heck, let's just write it. Remap. You can see how you might easily want a remap function too. And what a remap, all it does is it takes this map function and it just scales it between two destination values. So let's just, while we're here, let's just go and write it. So it's the exact same thing, only we are going to pass in two more values, which are just going to be destination values. So let's say output and output max. And we do all the same stuff that we do up there, but in, you know, a more concise way of writing this would be, what would that be? Let's see, the input max minus the input min. We can get rid of all these variables up here. And then the number minus the input min, and divide. So that's the same formula that we've got going on up there, just minus the intermediate variables to make it easier to read. And then if we wanted to scale this, what do we got to do? All we got to do is we just got to add the output minimum. So you got a value between 0 and 1, and let's say you want to have it go somewhere between two target values. And this is really common, actually. Like, let's say you want something to go from 0 to 100, let's say, opacity to 0 to 360 degrees. Then, you know, you might do a remap function. Like, okay, I know this is half opacity. I want to send it to 180 degrees if you have an interface that's taking degrees or something. Or yeah, let's say, you know, your destination output max, maybe it's tau, right? You want to say like, hey, I want to have this go to tau, 0 to tau. Then that's a really common usage. And so all we need to do to finish the remap function here is to return the output minimum. We just need to add that on the bottom, because remember, this can return a value between 0 and 1. So if you wanted to have it go to some other destination values like 0 and 360, just add it, and then you just have to scale it, multiply it by the difference. So output max, once again, we'll do an output max minus the output min, gives us the difference. And we'll scale this number here by that difference. So what's happening here? This is going to remap our value coming in between 0 and 1. And then this right here is going to add a bottom and then scale it up to the top. So that's your remap function. So map and remap, these are another reason I'm kind of mentioning these here is because they're super useful. You're going to use them all the time. So now we have our utility functions so that we can replace the index for our blend. And I think we've done a pretty good job of kind of working out the logic here. Now you notice I'm kind of repeating this a couple times, and anytime you find yourself repeating code, you know that probably what you really need to do is write a new function so that you can make reference to that function. So because I'm doing that, I'm going to come up here above, I guess, my shape functions, and I'll create a new, I don't know, I'm not quite sure where this should be, but I guess I'll just put it here. I'm going to make a new function called color mix. And I know that color mix, I'm going to pass in all the stuff that I have in my logic down here. And actually, I'll just go ahead and copy and paste this so that we have another copy of it. So that when I'm building the function up here, I have a little bit of reference. So let's see, I'm going to need the index. I'm going to need the color count. And I'm going to need a reference to the array. And the array is got a bunch of vec4s in it. The array is called colors. And I also need to tell it how many places are in the array. So five places in the array for this function to work. And then I'm going to want to have it return. It's going to return this. So instead of fill equals, this is just going to be returning that value, and it's going to be a mix. So let's come in here and let's copy and paste some of this code. Return the mix of these two things. Color count, I'm going to pass that in, so I don't need that anymore. But then I am going to need this. Let's keep this step value. Step value is equal to floor. So that's what I have so far. Okay, great. And I'm going to go ahead and build in some of that additional shaping that I had earlier. I'll just wrap this inside a max. And in 0.0 that we had, and I'll wrap that inside a min. And that min will be the color count. Okay, so the step value, when I pass in color count, it'll do that floor business we looked at Desmos earlier, and it's going to return 0, 1, 2, 3, etc. And then that step value is then going to be floated in here to the colors that it's going to return. All we have to do now is figure out exactly what needs to be here inside of index. And to make this a little easier to read, I'm just going to put in some carriage returns in here so we can break it into different components. And then know what I really want to do is I'm going to map the index that's coming in with some sort of values, a begin value and an ending value. So now all I have to do is figure out what those are. So begin and end. Okay, so what I need to do is figure out what the interval is going to be. And I've done that work already too. Like remember when I just divided by 0, or excuse me, divided by 1. So to get the interval is also really easy math. 1.0 divided by the color count. So once again, let's do this in our head a little bit. If our color count is 3 colors, right, that's going to give us 1.0 divided by 3. So 0.33, 0.66, etc. If this is going to be 4 colors, then 0.25, 0.5, 0.75. That interval, that even distribution of 1 is just going to be 0.25. And then we want the beginning to be, let's think about it as 4 colors. We want this to be 0.25 and then 0.5. Then we want this to be 0.5 and 0.75. And we want this to be 0.75 and 1.0, right, in the case of 4. So yeah, how are we going to do that? Let's see. Let's take that step value is always going to be changing, so we know we need that. And we need to add 1 once again, just like we did down here. And then we just need to multiply that by this interval. So this is going to be a value between 0. So I could think this would start with 0, and this would start with 1. And this would be 1, and then that would be 2. And then we just multiply that by this interval, which in the case of 4, let's say, would be 0.25. So 0 by 0.25 would be 0, and then 0.25 times 1 would be 0.25. And then we get 0.25, 0.5, and etc., etc. So let's go ahead and let's just multiply that by the interval. Great. Let's see, that's the end of that. That's the end of that. Let's save and see if we don't need that. And color count is giving me an error because there's a comma there I don't need. Very good. Okay, so no errors, so that's good. I've gotten rid of any errors I might have in my code. Now let's go ahead and let's use our handy dandy color mix function down here. inside our blend value. So fill is equal to, instead of mix, I'm going to get rid of all this stuff. I don't need it anymore. And instead, I'm going to call color mix. Let's go ahead and let's put those values in here in our color mix function. And I'm going to need my index, my color count, which I guess we'll just manually put in for now. And then I'll pass in my colors array. And there we go. That's returning something like that. Green to red to orange to green to purple. Let's increase the count. Okay, that's looking good. I noticed the end though, it's kind of let's see, it's going over the value. And let me take a look at my color mix function and okay, I see an error. This should be, the floor should be on the outside like that, because I want to, it wasn't clamping. So let's see, max index times color count 0, and then a min. We're going to need all of our matching parentheses there. And I can see my max. Let's see, I've got too many parentheses there. There we go. All right, so let's try increasing my count here. And we're blending between these different colors out here in space. Let's add some different colors and just test this real quick. That is pretty cool. That's giving us a nice gradient between all the different colors. What we should do next probably is change this from blend 2 to blend 5 to just a mode that's called blend, and then we'll get a slider for that.